Welcome to AI4. I hope you're having a great time so far. Our next session will be led by Richard Dutton. He is the head of machine learning for corporate engineering at Google. Please join me in welcoming Rich to the virtual stage.
All right, well, thanks for joining me, everybody. I am Rich Dutton. I'm head of enterprise AI at Google, or what we internally call corporate engineering machine learning. And yeah, today I'm going to tell you how using AI, our cross-functional AI team is saving Google hundreds of millions of dollars a year. First, a little about me. I have a bit of a checkered past with AI. I always loved math and computers, had my first computer at 7 years old. And so it was very natural for me to put those things together. And at university, I went to study AI. And that led into working at Microsoft around 2000 in Cambridge, England, and then Seattle, working in speech recognition. And it sounds like the dream opportunity. And in many ways it was, but anyone who was using speech recognition at that time will remember that perhaps the technology wasn't quite there. And so, much dog fooding of a system that really wasn't working to anyone's satisfaction. Later, I became a little bit disillusioned, and I left that group and left the US, moved back to the UK to take up what would become kind of a second career for me in finance. Worked doing quantitative modeling, again, kind of like very mathsy, so very satisfying, and got to live kind of across the world in London, New York, Singapore, managing teams in India and Tokyo. And it was really enjoyable. Got to cut some chops managing people. But, kind of as with the example before, at some point, I got a little bit dejected by the way that the finance industry was going. Around about 2008, obviously things took a bit of a turn, and they were still kind of, the shockwaves were hitting us even as late as 2014. And that's when I decided it was time to do something new. And of course, in the meantime, I'd noticed this kind of resurgence of AI and how successful technologies like neural networks were becoming. And I decided that that was what I wanted to do. I would leave Singapore, where I was living at the time, moved over to Thailand just to kind of re-educate myself in AI and ML. So reading papers, watching Coursera courses, reading books, blog posts, and got to the point where I was competent enough to get a role at a startup and then another, and then a hedge fund, and moved back to New York, spent some time in data analytics there before getting the opportunity to join Google. And of course, that's not an opportunity that you commonly turn down. So I moved to Google several years ago and initially worked on Bigtable, doing some ML stuff there before moving over to Google Assistant, which you can think of as Google's kind of flagship AI system in many ways. Spent some time there before I was offered the opportunity to run our enterprise AI efforts. And so that is what I'm going to talk to you about today. So as you might have noticed, Google does do a thing or two with AI. We have a research department of some 4,000 people. They're publishing papers and open source code that you can make use of, really that kind of run the gamut of AI technologies, anything from vision to machine learning fairness. And on top of that, we have a whole other group building TensorFlow and Keras that you can use to build and deploy your own neural networks, TFX, and then a whole other 1,000 people working in cloud AI, building these like high-level primitives to do things like speech recognition, text-to-speech, image recognition that you can almost just drag and drop into your own application through simple service calls. And of course, each of our products is like imbued with AI. Everything in many ways has AI at its core. All these examples you can see on my slide here are many, many more. And all of our sister companies in Waymo, DeepMind, of course, AI is absolutely critical to what they're doing. So it would be a little bit strange if we were running the very business of Google, the facilities like HR and legal and so on. If we were running the business of Google just off pieces of paper and spreadsheets, that would be very strange. And of course, that's not what we're doing. We have AI at the very core of the way that we operate as a company. And we're using AI across all of our internal business processes, which of course are pretty much the same processes that you have at the heart of your company. And certainly like the majority of mid to large size companies are going to share so much in common with what Google is doing there. So the structure for today is I'll talk first through some of the business challenges that we're using AI to solve. And then I'll talk about how we built a horizontal enterprise AI team and how it operates with the other enterprise IT teams at Google. And finally, I'm going to share some tips and tricks, some things to keep in mind, some things we've learned along the way as you go about employing AI in your enterprise. And there are many, many things that are particular to enterprise AI to be borne in mind. A lot of them around data privacy, as I'm sure you can imagine. So first, I want to talk through those business challenges. As I've mentioned, we're really using AI across all areas of the business of running Google. But today, I want to focus on 4. I want to talk about support, HR, facilities, and communications. And through those, I think we'll see a set of technologies that are emblematic of the kinds of work that it's possible to do, both for Google and for you. So, like yours, Google's employees need a lot of support. In fact, if you know anyone from Google, you probably know that we're a fussy, difficult bunch, and so perhaps more support than most people. We have one ticketing system through which we can file requests, anything from certificates expired on my computer so I can no longer connect to the network, to HR requests inquiring as to my benefits, say, or kind of slightly more frivolous things along the lines of, please can you change the flavor of the chips in the micro kitchen, or can you restock the decaf coffee, so on and so forth. So this one system is getting kind of inundated by tickets. We're talking about tens of millions per year. And at the scale that we're operating, just kind of routing those tickets around, you're taking them from the user's submission, getting them to the right person to solve that problem, that could cost an absolute fortune. And prior to my team coming along, it was. So my team came along and looked at the ticket routing problem, and we say okay, we've got some text features here, we've got some non-text features, but the text is the most important stuff, most interesting stuff. And we can nowadays we have access to these tremendous NLP models that allow us to embed that text in a vector space in such a way that we can then pass it kind of downstream into neural networks or other model architectures. And ultimately we want to assign that ticket that text corresponds to one or other kind of business areas and queues. And that's just a simple kind of multi-class classification. So you can think of putting a softmax on the end of your neural network, and you're pretty much done. But we can then go the next step, and we've just deployed a system that actually makes suggestions to resolve your issues as soon as you file them. So the way that we do this, it's a little bit similar. This time we're encoding the text of the ticket as well as the text of answers from the historical record that we have access to. And we encode them through what's known as a dual encoder or two-tower neural network architecture. And the way those work is that very cleverly, the network learns to place questions and answers close to each other in vector space if the answer answers that question, and farther away if it's less relevant. And in that way, when a new question comes through, we put it up the one tower of the network and we get an encoding. And using a kind of nearest neighbors at scale kind of algorithm, we can retrieve all of the answers that are closest to answering that question, and we can offer them back to the user. again, saving tons and tons of time, both the user waiting to talk to someone to resolve their issue, and also, of course, the person having to actually resolve that issue. And in the process, we've actually managed to kind of improve the user's privacy, because this is now two people that we cut out of the loop of looking at that user's data, which, as I implied with the HR example, can in cases be quite sensitive. Taking that to the next step, something we're working on now is kind of integrating this end-to-end into a virtual support agent. So, chatbots are popping up everywhere now. We have access to a lot of great chatbot technologies internally, but externally too. Google's Dialogflow, which we're using for this, is accessible on the cloud. And so using that, we can guide a user through a multi-step process from kind of the initial specification of their problem through clarifying questions to testing out potential answers to resolution. And then, however we get to resolution, we want to be able to do some analytics on the mass of these support tickets that we're seeing. And at the volume we're talking about with this kind of like free-form text structure, that's not trivial. But something we put into production a while ago is a clustering solution where we take the text, again, we embed it using one of those language models. And once it's been embedded, we can do clustering on it and in such a way that similar tickets end up close to each other in vector space. And so we'll get a cluster will appear for, say, networking issues in New York or something like that. And in that way, we can see kind of where we're spending our time. But kind of taking that one step further, we can actually look at the trends in these clusters over time. And that's something we deployed a few months ago, actually just in time for COVID. And that enabled us to see kind of all of the search, kind of like all the groups of search terms that were spiking under COVID. And the beauty of these language models, as I'm sure you know, is if people could be using completely different words, but if the intent is the same, then something like BERT will capture that. And we'll cluster these things and be able to do that trends analysis on them and see, oh, lots and lots of people haven't been prepared to work from home for an extended period of time. Their laptops are still gathering dust in a wardrobe. So that's been tremendously helpful for us in being much more proactive in responding to COVID, to work from home, and I'm sure in the future to return to office. So, having talked about supporting our folks, I want to also talk about how we develop them. Our people are very, very important to us, and continuing to grow them over the course of their career equally important to us. So we put a lot of time and effort into our performance management system. I can tell you it takes up a lot of my time as a manager. And one of the things that we do in performance management is everyone has to specify a fairly long list of peers who will give feedback on a given individual. So I might specify like 12 peers. And of course, it's difficult to think back all that time to who the people you've worked with who could give most relevant input into your performance for your manager. So that's an area where we have a simple model, and it actually looks at the kind of public record of interactions between people. If people have been in meetings together, if they've been contributing on our source code system together, code reviewing each other, participating in documents together. And that way we can kind of gain a long list of people who are working together, and we can actually filter that down to a short list of the folks that we know people would choose if they gave it some thought, again, kind of training from the historical record. So that system's been tremendous for not only saving people that time, but also getting like better quality peer reviewers and ensuring that people don't forget folks that they worked with months and months ago who could give some really concrete, useful input. Of course, kind of coming out of the performance management process, you want to start developing people based upon the kind of areas that have been identified. So here we can use simple recommender systems, the kind of thing that you would see on YouTube or Netflix, in order to suggest courses for folks in line with their learning objectives, and suggest mentors for people that are most likely to be able to help them reach their goals. Relatedly, at some point, no matter how much we love our job, we all want a change. And when that comes, we don't want to lose the people that we've painstakingly hired and got through that infamous Google hiring process. So here we can suggest internal roles for folks. Make sure that we keep them within the company. And also something I wanted to talk about in the context of COVID, space is at even more of a premium than it ever was, and it's always been challenging for us. So optimizing our use of space is another area where we can use AI techniques. We have relatively well understood optimization algorithms, but more and more we're seeing that we can use deep learning to approximate those algorithms, or just to tell us whether they're likely to have a successful resolution or not. And one example where we use this is with meeting rooms. Always have been heavily contended. Used to have to specify which meeting room you wanted to have at what time. And of course, that's very inefficient. And it robs us of the ability to kind of right those rooms to people, put people closer to rooms that are actually closer to them, free up rooms appropriately. So this is something that we've deployed models to effectively do all that work in the background, so you don't have to specify a room. It gets taken care of for you by an optimization process. But our process is lengthy, so we have a deep neural network model that runs before that just tries to guess the results of that process, or at least guess the success or failure of that process, and such that when you're booking a meeting, you'll have something that says okay, you've got a 95% chance of getting a meeting room automatically. Don't worry, go ahead. Or if you're trying to book a meeting room at rush hour, then the tool will say, actually, it's very unlikely that even with our best efforts, up to the hour before the meeting, that we're going to be able to find you a room. So give up now and book your meeting for a less contentious time, less contended time. So also key for folks' well-being are the office facilities that we work in and the comfort levels that they provide. We have, I couldn't tell you how many campuses across the world, and each campus is littered with buildings. And each one of those buildings, many, many floors, just stuffed full of hardware like air conditioning units and so forth. And those pieces of hardware are, of course, wont to fail. Google pretty much built a business in the early days of working around the fact that hardware is not 100% reliable. And so, knowing that things are going to fail or they're going to be installed incorrectly, we want to find those cases, and we want to be able to proactively send engineers along to look into that. But we don't have great labeled data. We can't build a supervised algorithm for this. And actually, these units are entirely heterogeneous. Different units produce different streams of sensor values. So we had to think about this quite hard, and ended up building a fairly unique system where we do anomaly detection on the sensor streams coming out of these air conditioners and all the other electronic units that we have connected to the network. That system automatically configures itself according to what it sees in the output from the system. So there's no real config required. And someone from my team developed an innovative neural network approach with negative sampling and interpretability, so that we can see both in a univariate context or a multivariate context where a sensor, a piece of hardware sensor values are not working as we would expect, or it's not behaving well with respect to its peers. And in that case, we can actually tell the engineers not only that it's misbehaving, but we can usually give them an idea as to why using interpretable neural network technologies. We can say this HVAC is not working, and we think it's because the fan is pegged on, for example. So that's been tremendous for us, tremendous cost saver as well, finding all of these over and under provisioned air conditioners. We found air conditioners fitted backwards, air conditioners that are about to about to pack up altogether. But another area where we can save potentially even more money, and to be honest, it's even more exciting. And I didn't mention actually, but that anomaly detection, the person from my team published their paper at ICML this year. His name's John Sipple, so you can check that out. Pretty exciting stuff. But we all know that the most exciting stuff in AI at the moment is all around deep reinforcement learning, as you would see in self-driving cars, AlphaGo, and so forth. And that's technology that we can make use of as well. Again, we have all these buildings, all these air conditioners, spending a fortune on cooling them. And that's something that we can actually optimize with a DRL agent, and something that DeepMind showed could be done with data centers some years ago, and something that my team now has a proof of concept that we're hoping to put to production this year, of doing that in the office space. So another area, maybe a slightly funnier one, where we can save tons and tons of money is in the cafeterias, at least when we do finally return to office. Back in the days before COVID, I would be going into the New York campus, and I would have access to something like 9 restaurants on a given day. And which one I'm going to go to will depend on, of course, a variety of factors: what they're serving, where my friends are going, what the weather's like, if I want to sit outside, so on and so forth. So the chefs in any one of those cafeterias have a pretty hard problem predicting how much food to cook. And if they cook too much, that's wasting money and it's harming the environment. But if they cook too little, then you end up with dissatisfied Googlers. So my team built a fairly simple, actually, regression algorithm to predict for each cafeteria how much food they should be cooking in accordance with those factors that I mentioned before. Finally, another area where we've been able to save crazy amounts of money, and actually in this case with very little investment on our part, has been in inventory management. You can imagine, as a huge company, probably like many of yours, Google's sitting on stockpiles of computers of all kinds, of these HVACs and just about anything, tons and tons of hardware. And when you're holding all that inventory, it's a very costly process. And there are situations you want to avoid, like holding inventory that has become kind of stale, is now deprecated. So my team built an algorithm using AutoML, whereby we pretty much just show the system our data, and we showed it a historical record of deprecated technologies. And it's learned to predict that many months out, so that now we're actually saving on buying into those technologies that are ultimately going to be worthless to us. And that is saving us tens of millions of dollars alone. And actually, in this case, because of that use of AutoML, which really expedites all aspects of the machine learning workflow, we did that in about 2 person months. So just an incredible return on investment that's possible if you find the right area, and then if you can bring AutoML to bear on it, so much the better. So the final area I'll talk about today is communications. Communications have always been critical, and communication technology at Google and everywhere now. But of course, in these times, even more so, we're all talking to each other over video. Everyone from Google is running video conferencing. Some of us all day long, it feels like. And many of us even have dedicated video conferencing units on our desks, even at home. But in the office, even more so, we have all of these meeting rooms. Every one of them has a dedicated VC unit. And again, as with the HVAC example, anytime you've got all those VC units, you know that a number of them are going to be on the blink at any time. So no problem, we thought we'll just kind of apply anomaly detection to this. But it turns out the data format is much, much more complicated. We were having to look at log files and trying to figure out how to parse those. And when we started this a couple of years ago, we were getting somewhere, but we weren't getting close to the target metrics that we'd set on with our business partners. So I've drawn this one in red because ultimately, some things you got to give up on. This one we did put on the back burner, and nicely enough, we're going to pick it up again this year in all likelihood, or at least next year, Because as I've mentioned, like we now have access to these transformer-based models that are going to allow us to do a much, much better job of encoding those log file entries in a way that will work well with, effectively a kind of numerically based anomaly detection system. So another area that I've actually touched on a couple of examples of already, but something that's there's just so many examples of within Google is document classification. Design documents, for example, or like documents coming in from the outside world, requests for this, that, or the other, internal documents, actually determining what the type of a document is, what its purpose is, what we're expected to do with it is a big chunk of work. And of course, something that, as I've explained with the ticket routing, it's very simple to do with machine learning now. So we've got tons of models doing document classification. But one thing I point to is it can be really helpful to also include interpretability technologies here. So we've made use of integrated gradients, which I'll talk about a bit later, in order to highlight the words in a given document that make us classify it as this type versus that type. And that's tremendously useful for these kind of human-in-the-loop processes, where you want to actually review the decision of the machine. Something that's been very new to us, perhaps because the technology's just come of age, and also because it happens to be very, very useful to us in these times of working from home, consuming so much information kind of from the screen in textual form. Document summarization. So we have built out integration between our chat system and a summarization agent, such that if I go away for any significant period of time, come back to my computer, and I've got these chat channels with like hundreds of messages in, those will get condensed down into a kind of 5-message or kind of 5-line abstractive summary. We use the Google Pegasus model, but there are tons of models out there now for doing this. You can do it with email, do it with typical documents, chat, as I've said, tons and tons of opportunities to do this. And it's saving hundreds of thousands of hours. And another thing you can do with documents, once you've encoded them, is look for document similarity. I mentioned clustering, but you can also just look at how similar is this document to this other document or any other document I've ever seen. What are the most similar documents to this particular one? That proves very useful in deduplication. An interesting example is with design documents, we can do it. And if someone is writing a design document that's a bit too similar to someone else's design document, they probably don't need to actually spend the time doing that work. So that's what we're doing. And now I'll tell you about the team that we've built to do it. So there are 2 aspects to doing this successfully. We obviously have a large swathe of existing enterprise IT teams, and we want to empower them to do whatever of this work that they can. But key to doing that, we have, as I've mentioned, our own enterprise AI kind of horizontal team that partners with them. And together, we're able to do a ton of stuff, but also to do it in a high quality and respectful way. So the mission we set for our team was to use applied AI as competitive advantage for Google in the enterprise. And the way we're going about that is, as you might expect, we're doing some implementation work. Historically, we did tons of this, building models for everybody. And now, less and less, as I mentioned, because more and more, we want to be moving towards that central pillar, the empowerment of others. And if we can empower those existing enterprise IT teams to build their own models or build their own models in consultation with us, especially using these technologies like AutoML, then we free up so much more of our time to either work on those higher value things I mentioned, like anomaly detection is something we've been able to deploy over and over and over again. And something where we've kind of really designed something cutting edge from the ground up, but also allows us to focus on interesting areas of research that are really critical to doing enterprise AI right. And I'm going to talk about that in the consideration section a little bit later. But you can think of things like fairness and so forth. So we end up kind of spending a lot of time staying on top of research, while helping others build their own ML models, making sure they don't shoot themselves in the foot, and then building our own models for those like highest value, kind of oftentimes most reusable and most complex use cases. And this is what our team looks like. We have a number of leads. There's myself as the overall team lead, and I have regional leads in New York and Austin, sorry, what used to be New York and Austin, and now people have been scattered to the four winds. So we also have a program manager who's critical for keeping on top of the myriad things that we have going on at any one time. With the stop-start nature of the work that we're doing and the fact that we're kind of helping others and so forth, we've often got every engineer involved in at least 4 different activities. So someone's got to make sure that we're not dropping balls left, right, and center there. We also have a product manager, something we added relatively recently, and I've just found that invaluable for making sure we're going after the most impactful of the opportunities in the space. Keeping in touch with all the other product managers. As an engineering manager, of course, that's not necessarily my forte. And also kind of defining very kind of like otherwise ill-defined projects. So the number of times someone comes to us and says, I want a chatbot, and having the product manager who can go off and actually drill into what they really need to actually wring the most business value out of it. And of course, most importantly, we've got tons and tons of engineers, although far less than you would think, because as I mentioned, we're able to get a number of things going on with each one of our engineers simultaneously. We have a number of interns whenever we're lucky enough to get access to them, and we also make a great use of 20% resources. So you may have heard at Google there's this like 20% time notion, and it means that anything I'm sufficiently interested in, I can just volunteer my time to. If I want to go back to Bigtable and implement something there, I can spend 1/5 or 1 day of the week doing so. Of course, when you've got an AI team, everyone's tripping over themselves to volunteer to work for you for free. So that is tremendous. Now I want to talk a little bit about those considerations that I mentioned. Really, these are areas that if you kind of naively go about building models, perhaps with someone who just joined the team with a master's in machine learning and starts throwing stuff out into production, if you don't think carefully about these areas, you can cause yourselves and others real problems and add a ton of risk, including legal risk, to your business operations. So these are the areas that, as a central team, as I've mentioned, my team is thinking about all of the time, both in the work that they're doing and in their support of other people across enterprise IT. So privacy is something that we've all heard a thing or two about in the news. Pretty much every day, it seems, it's coming up. And we want to be as respectful of people's privacy as we possibly can be. In fact, we're forced to be, even the tremendous policies in place to make sure that we are. And there's a lot of opportunity with privacy, as I mentioned, with AI. The more people that we can take out of the loop, the more privacy someone's going to get to enjoy. If someone's not having to manually process their tickets or respond to them. So models really can be a boon for privacy, but deployed, should we say, in a manner that's not judicious, models can be a real privacy threat. As you may know, it's possible to build models which an attacker can effectively query to understand or in many ways get access to the underlying data set from which you built that model. There's even an XKCD cartoon along these lines, so that it must be a thing. So differential privacy allows us to do queries or even build deep neural nets using DPSGD in order to build models that are not subject to that risk. Federated learning is most commonly known to people, or at least most commonly used by people if you're using smart keyboards. Of course, we don't want all of our text being sent over the internet to someone's cloud provider, whoever they are, whichever company it is. So these systems actually do like learning on your machine, on your cell phone, say, and then they're just shipping something like model changes, model impacts back to the central system, and your privacy is preserved. Yeah. Secure computation, probably the most amazing of all of these things. I have never delved into it enough to understand it. So for me, fortunately or pleasantly at the moment, it just has this charming quality of magic whereby we can run math, and that means effectively like train models on encrypted data, make predictions on encrypted data without even decrypting it. And we have remote execution that allows us to train models kind of like at a distance. So absolutely critical anytime you're using data of an individual or of people. Privacy is something that you should be thinking very hard about, and treating your internal employees like you would treat your customers, paying them the absolute maximum respect here. So if you'd like more details, you can see in the bottom right there's a link with more details on kind of how we at Google go about thinking about privacy. Get more details on these technologies and many more. So another area of critical importance when you're working with data about people and affecting people is fairness. You've seen again examples in the news of like biased models making terrible decisions. I think there was one from the UK, my home, or at least my former home, recently. And these come up again and again because in some ways it's fundamental, at least to the way that people used to build models. And we know that models are effectively a model of your data. So if your data has bias or fairness concerns, then you're going to, of course, see that in the model that you build. And remediating that is not as easy as people often think. There's a lot of ways in which you can remediate or attempt to remediate fairness concerns, whereby you actually make the problem worse. So I've just put up here, a fraction of the list of publications in this area from relatively recent times. This is a list that just continues to grow, and a large part of how my team operates responsibly within the enterprise is that we are reading, not everyone, but someone on the team is reading each one of these papers, staying on top of what's happening, talking with our internal ethics boards, and making sure that whenever we do even the most innocuous things like the peer review suggestion that I mentioned, making sure that we're doing that in a way that is respectful to all people of all demographics. And again, I've got a link here in the bottom right with more details. So the final thing I put under the category of kind of challenges here, and also of exciting research technologies, is interpretability. I mentioned it already in the context of documents, where we could highlight the words in a document that made us classify that document one way or another. So suppose we have a model whose raison d'etre is to classify an image as containing a clock or not containing a clock. And we run our model on this image on the left here, and fantastic, it determines that we have a clock. We're in good shape. Then we run our model on the image on the right, and the model says, actually, this is a clock. And we know it's not a clock. Of course, it's not a clock. Some kind of small child. So why is the model doing this? And more broadly, just understanding why our model does what it's doing helps us avoid models capitalizing on spurious correlations, which don't actually generalize in the real world. Help us avoid models that are going to act in an unfair way by looking at aspects of the data that we'd really rather they weren't making decisions on. This really is the way to kind of, step into the debugger of your model. And it's an area that Google and others have been spending tons of money and hours on figuring out. The term black box neural networks is something that I almost kind of like giggle internally when I hear now, because I know how good the results are that my team's able to get just by using the technologies that are available pretty much off the shelf. Many of these things are in GitHub and papers are all published. So here we can see in the middle the result of running integrated gradients in this hypothetical case. And we can see the pixels kind of highlighted that the model is paying the most attention to. And yeah, of course, we can see this does kind of, if you squint a little bit, start to look a lot like a clog. And armed with this information, we can go on to fix the model's interpretation, either by changing the source data, the training data, doing some additional feature engineering, whatever it takes. Integrated gradients, which I'm mentioning here, is one of the technologies that we've had a lot of success with, but it's just one. There are others along the lines of TCAV, TCAV, which allows you to look at things at more of a contextual level. So classic example could be, is like, are you saying this is images of a zebra because of the horsiness or the stripes? And there's a technology that builds on integrated gradients, especially for images, called XRAI, which oftentimes produces more kind of like even more interpretable examples than we can see in the center here. And there's a newer technology, tracking, which I recommend people take a look at too. Again, the bottom right-hand corner, we've got a link to many, many more details in this space. So now I want to talk a little bit about AutoML again. I touched on it before in that inventory management example. So this really has been kind of like the good news of the year for my team. Like, this technology is the one that is allowing us to scale far more than we ever have been before. AutoML is effectively the process of using AI models to train new AI models. And so rather than having to go through all of the manual feature engineering, your model architecture, building and tuning, with AutoML, we pretty much just take our data with some kind of like target column, which we can flag to the machine. And whether that data is structured data in tables or image data or text data, we throw it into AutoML, and AutoML, almost by magic, tries huge combinations of architectures in order to find one that performs the best. And it's kind of hard to overstate how well this is working now. You have to burn some GPU cycles in the process, but if I go into a head-to-head with AutoML in a Kaggle competition, there is no way that I'm going to win. And I'm not going to get beaten by a small amount either. And even against like Kaggle grandmasters, AutoML has been coming up kind of, first and second in the leaderboard. So it's really impressive, not just the performance that you can get from AutoML, but also just the speed with which you can turn things around. I mentioned deployment straight to production in could be like 1/5 or 1/10 of the time that you might ordinarily have, and with such great results. So more details again at the bottom right there, but I will recommend at least having a play with AutoML, if nothing else. So now I'll challenge you to go away from here and think about opportunities in your own business to apply these kinds of techniques to make the most of AI, to save yourselves money, reduce risk, and capitalize on opportunities that you might not have even noticed before. To do so, probably you want to build an enterprise AI team if you don't have one already, and ensure that they're working in the optimal way with the existing enterprise AI teams. And the other thing, of course, that you want to do is make sure that they're aware of all of those complexities that we've touched on, the privacy, the fairness concerns, the interpretability. Make sure that they're employing research to address those issues, and also employing research through the form of AutoML to 10x their productivity. With that, I'll say thank you very much.
Awesome. Thank you so much for that awesome presentation, Rich. We all learned so much and we appreciate you, and we're giving you a big virtual round of applause. All right, if you're headed to your next session, you can go ahead and check out your agenda to find where you're headed next, or you can take some time to do some one-on-one networking with your peers or visit our sponsor virtual booths. Thanks so much, and we'll see you around.